show that violating the put-call parity in the formulation that we have just seen, so the value of the call minus the value of the put needs to be equal to the value of the underlying asset minus the value of the discounted strike, show that if we violate that, then we can build an arbitrage. So we can build a strategy, we can build a portfolio that costs nothing at time zero, and that gives almost surely a positive return, or for sure, no loss. Now, how can we do that? As follows. Now, without any loss of generality, just to simplify a little bit the treatment, but it's not necessary, so you can easily, and I give that to you as an exercise if you want, you can easily restate what I'm doing here without the assumption to be at the money forward. So what do? We assume that for whatever reason, because we have naive expectations on the evolution of prices, because we have some information from the past, because our grandmother told us so, we decide that K is equal to the cumulative value according to the risk-free rate of the price of the underlying asset at time zero. So we set K equal to S0, which is the value of the stock today, times E to the power R capital T. So it's like we take the decision that K is equal to taking the price of the underlying asset and investing the price of the underlying asset at the risk-free rate. If this is the case, we have that the strike will be equal to the cumulant of the price. And we say that this is the hypothesis of being at the money forward. If you choose that K is equal to S0 e to the power RT, obviously when you discount K at time zero, this is equal to S0, okay? So trivially the case. Now, we know that the put-call parity tells me that C minus P is equal to ST minus K discounted to time T. Now, if we go to time zero, and this needs to be equal for every T, from 0 to capital T. Now, if we do the math, obviously, this is also true at time zero, but then we have that according to the call put parity under the hypothesis that we are at the money forward, then the difference between the call and the put needs to be 0. Why? Because the value of the call is C0, the value of the put is P0, and this value needs to be equal to the difference between S0 and the discounted strike price in 0. But S0 is S0, and K discounted to time 0 is equal to S0 e to the power R capital T times E to the power minus R capital T. So the two exponential parts compensate. What remains is S0 minus S0, okay? Just substitute the definition of K using the at the money forward hypothesis. And consider the fact that we are considering time T to be 0. So we are in small t equal to 0. Now let's assume that this is not true. So let's assume that we violate the put-call parity. If we violate the put-call parity, we can say, for example, that the difference between C and P is positive, and it's equal to some X, which is strictly larger than 0. If you want, you can also do the opposite. You can assume that the difference is negative so that the put is, has a value which is larger than that of the call. Obviously, you will slightly change the strategy that I will tell you in a minute, but it will work in any case. So if we assume that the call is worth more than the put, then we can do the following. At time 0, I short sell the call. So I come to one of you and I short sell the call. That means that I'm selling you the call without having the call in my hands, okay? I'm taking the promise that I will give you the call in the future. But at the moment it's not there, but I short sell that to you. If I do that, what I receive? I receive the value of the call. The value of the call, by assumption, is equal to P S00 plus X, because we are assuming that the difference is positive. So I can take the P on the other side, and by short selling the call, I receive a value which is the value of the put plus X. Now, with the value of the put, I buy a put. So now in my portfolio, I have a short position in the call, because I short sold the call. I add a long position in the put, and I still have X that I'm assuming is positive. I take this quantity and I invest X in the risk-free rate. So I put that X in the bank account at the risk-free rate. Then I do the following. I also enter in a forward contract. And the forward contract I enter into is a contract in which at maturity, I will receive S capital T minus K. Obviously, if S capital T minus K at maturity is positive, I actually receive that money. If it is negative, I will actually pay that money to the counterparty, because remember that in a forward, there is no optionality. So you either receive or you pay money. That's it. So if you take the value of this contract, if you take the value of the forward contract, since we are assuming that we are at the money forward, that is to say that K is equal to S0 e to the power R capital T, if I discount S capital T and I discount K to times 0, essentially what do I have? I have S0 minus e to the minus R capital T multiplying S0 e to the power R capital T. So once again, they simplify and the value of my forward in 0 is equal to 0. So what happens? The value of my strategy is what? I have a short position in the call, but the call is worth P0 plus X. So my position would be minus P0 minus X. But I use that money to buy the put, so I have plus P0, and I put the X in the risk-free investment, so it's plus X. Then I add the value of the forward, which is equal to 0. So the value of my strategy at time 0 is just 0. I'm able to build a strategy that costs me nothing because I'm putting no extra money from my portfolio, from my pocket in the strategy. I'm just short selling, buying, and doing anything without adding real money from my pockets, from my bank account to the portfolio. Now, once I have created this strategy that for me has a value 0 in 0, I do nothing. So I just sleep, I go outside, have an ice cream, I walk in the beautiful streets of New York or wherever you are. And I wait until capital T. Okay, so I wait until maturity. In maturity, what happens? I can see what is the value of my strategy at time capital T. And I discover the following. At time capital T, I will get, because I have a long position in the put, I will get the payoff. And the payoff of the put is K minus S capital T. So this quantity can be positive or 0. I will pay what? S capital T minus K, because I have a short position in the call. And this quantity can be positive or 0. But notice that it's not possible that both the put and the call are positive at the same time, because either the price is above K or it is below K. So either I have the put and I receive money, or I have to pay for the call, okay? But this possible difference in the put and the call is compensated by the forward contract, because you will see that the forward contract by definition will always have a value that compensates either the put or the call. So the forward is a contract that gives me the possibility of receiving or paying money depending on the difference S capital T minus K. And finally, since I invested money in the risk-free and I invested X in the risk-free, at the end of the period, I will receive with certainty, because it's the risk-free, the quantity x e to the power r capital T. So what happens? The value at time t of my strategy is just the sum of all these possible payoffs of the sub-elements of the strategy. That's the payoff of the put minus the payoff of the call plus the payoff of the forward that can be positive or negative plus the payoff of the risk-free investment. Now, as I told you, the forward will always compensate the positive between the put and the call. So what happens is that at the end of the day, what remains for me is just x multiplying e to the power rt. But this quantity is, by definition, positive, because x at time 0 was positive, and I have invested this thing in the risk-free rate. So I have a positive value at the end. So, and this is even almost sure, because it's the risk-free rate. So I have something, I have a strategy that costed me 0 in 0 and has a positive return almost surely at maturity. This strategy is an arbitrage, and I was able to build this arbitrage because I violated the put-call parity. Because the put-call parity is a necessary, yet not sufficient, but this is a little bit subtle, you need much more information to verify that, condition for the absence of arbitrage. Please notice that this type of exercise, exercise 2, is quite common. So try to familiarize with the put-call parity and try to see again, watch again the video of this lesson, read again the slides, or have a look at my lecture notes that you find in the course website under lesson 6 to find more details about this type of exercise, because it's quite important. You already see here the beauty of financial mathematics. We have actually a formal proof that violating a condition like the put-call parity, which is not just something that we set from a mathematical point of view, but it's actually something that has profound financial implications.